Picture the modern technology keynote, the breathless headlines, the dark stage, the executive pacing back and forth beneath a giant screen. We are told that a radical new capability was invented this very morning, and we all play along. We participate in a ritual where we agree that the underlying machinery sprang into existence the moment the CEO stepped into the spotlight, ignoring the similar systems that were already running in military programs and intelligence labs decades ago. On May 1, 2000, every civilian GPS receiver on Earth suddenly became 10 times more accurate overnight. No new satellites launched and no hardware shipped. The precision had existed the entire time, orbiting overhead, reserved. That morning, the public was finally granted the same signal access as the military. 3 years earlier, British intelligence made an even stranger confession. They revealed that the mathematics securing the modern internet, the cryptography used in every online purchase and private message today, had been invented inside their walls between 1969 and 1973. For a quarter of a century, the outside world worked to reinvent mathematics it sincerely believed was new. This distance between the moment a capability demonstrably works and the moment the general population is authorized to hold it is the permission lag. This same structural delay is what obscures the true state of artificial intelligence today. Every brand new tech launch is actually built on 3 distinct stacked historical intervals. At the base is maturation, followed by permission, and finally perception. Maturation represents the honest interval required by physics and engineering to improve fabrication and lower costs. But the permission layer is an administrative choice, constituted by classification regimes, export controls, and strategic withholding. Finally, the perception layer arrives as a marketing blitz. It is engineered to collapse those decades of development into a single day, ensuring the launch date overwrites the true invention date in public memory. Strategic withholding has a shelf life. As competitors catch up, or the cost of maintaining the secret exceeds the intelligence value of the original advantage, the gate eventually opens. Releasing a technology is often a calculation that the differential has finally been spent. When that happens, the withholding instrument simply climbs. When the global GPS signal was cleared for civilians, the military simultaneously announced its new regional denial capability. The enclosure moves to a higher, more classified tier, while the public receives the legacy version. Every brand new launch marks the graduation of a capability from its restricted habitat into the public sphere, scheduled entirely by elite strategic accounting. You might assume none of this applies to AI because older computers lacked the processing power to run it. We tend to view machine intelligence as a new category of technology that requires massive modern data centers just to breathe. In 1998, however, software called DragonPen was running locally on a standard Palm Pilot. Using a modest processor, it successfully classified more than 5,000 handwritten Chinese characters in under a second, proving that pocket-scale intelligence was already operational decades ago. By 2003, researchers had a complete machine intelligence stack running on a 206 MHz handheld. It executed speech recognition, natural language parsing, and translation entirely on the device, with performance comparable to the desktop systems of the era. Even the supercomputing power needed to train foundation models existed a generation ago. In 1996, the ASCI Red supercomputer broke the teraflops barrier using 9,000 commodity processors. The raw computational capacity was already in place. The divide between a home computer and a teraflop system came down to a federal purchase order and an intelligence appropriation. This capability was simply locked behind classified defense budgets, making it invisible to the average consumer. We consistently suffer from a geographic fallacy. We confuse the civilian possibility frontier, the hardware we can buy at a store, with the absolute institutional reality that is hidden from us. This same structure of suppression is operating right now, in public, across the modern artificial intelligence landscape. The most capable frontier systems are currently withheld from general release. They are placed behind statutory pre-release windows and deployed on classified Department of Defense networks, accessible only to vetted institutional cohorts and security agencies. We can see this in the process of distillation. An expensive teacher model is trained inside a massive capital envelope, and then compressed into a smaller, simplified student version. That student model is the artifact that is eventually authorized for public release. This creates a tiered architecture where the democratization of AI actually refers to the distribution of a legacy tier. The public gains access to the inference, while the capacity to produce the next teacher model remains centralized at the top. This provides us with a new protocol for every future launch day. When a headline announces a technological breakthrough, do not look at what has arrived. Look at what the arrival makes room for. When you see the public finally handed a gift, do not ask what was just invented. Ask what the people at the top just moved on to.